So 1, 2, 3, 4, 5, 6. So this one pairing. Maybe if that is 5 means now this one denoted as that is the unpaired electron. If it is still that is 6 electron, this one pairing. So 2. Okay. So second concept according to this, they are saying that is no magnetic, that is the field. So why no magnetic field occurs mean? Because here 2 electron. So this one that is motion clockwise. Maybe to consider this one for plus half. So this one minus half. So the net force. So this one attraction, maybe repulsion. So now the net charges, that is the 0. So now the magnetic moment, that is 0. Okay, third one, that is suppose the magnetic field. That means, so now randomly just we consider this electron. It is a bit, that is already told, that is no force. Okay, maybe now here the electron, it is in random motion. Okay, not uniform. So here and there the motion takes place, electron. Okay, that is electron dipole. So you know very well that is electron dipole means that is the positive and negative charges. Okay, so now to apply the magnetic field, external magnetic field, that means now to keep the magnet here, now to produce the magnetic force, magnetic field, it is created. So this magnetic field, whenever it is kept near here, now to produce, give the output is this electron, that is motion uniformly, condition number 1. So next one, the motion, it is in opposite direction. So now draw this line, this like, okay. So now this one, oppose this applied magnetic field. So due to this 3 condition, whether the element or material, it behave as this diamagnetic. Now you see this example, you can again understand very clearly. So see this, especially here, that is the transition, that is the element. So scandium, Sc, here plus 3, copper, plus it is in ionic state, Zn and plus 2. Okay, so now first take this copper, that is ion, take this example. So now take the elemental state copper, atomic number 29, electronic configuration, now writing without this noble gas. Okay, so 3d9, that is 4s2. Okay, so next one, that is 3d10, 4s1. You know the reason also why I am writing this, due to the symmetry, that is transfer the electron from s orbital to d orbital. This concept you know very well. Okay, so in Cu plus, the electronic state is 3d10 and 4s, that is 0. So now in d orbital, that is 10 electron, it is completely filled, it is paired up electron, all the electrons are, that is pairing. So it is diamagnetic in nature. Okay, so how come to the conclusion? Say this 3d orbital, 10 electron, so completely filled, that is pairing. So all electrons have the orientation pairing, so it is diamagnetic in nature. See the next example for Zn, that is 2 plus. Okay, so zinc atomic number 30. Electronic configuration 3d10, 4s2. So Zn plus 2. Now this electron, that is 0, 4s0. That means 3d10, 4s0. So now d orbital, that is 10 electron, all the electrons are pairing. So it is Zn2 plus R, diamagnetic in nature. Come to this third example, Sc, scandium. Okay, atomic number 21. So 3d1, 4s2. So in Sc, in ionic state, in Sc plus 3. So plus 3 means this 1 electron, this 2 electron, that is last. So the electronic configuration is 3d0 and 4s0. Now compare the previous example, here 3d10. that is electrons, all electrons are paired up and completely filled. But here 3D, that is no electron. So even in absence of electron in 3D and another one completely filled, so now both the condition, now the element, it behave as diamagnetic in properties. Students, I hope all the students are understand very clearly. So next class I am taking this paramagnetic and ferromagnetic and antiferro. So this one that is studied very clearly. So now I recall. So magnetic properties explained based on this electronic configuration. So in electron, that is the motion takes place. That is a two type of motion. One is spinning and another one is orbital. So orbital. Okay. So go through it clearly.